Hi, good day. My name is John Vincent Saracanlao, and this channel is about research and research statistics. So today's topic is about correlation, coding and correlation. The importance of how to code progressively, even if it's a nominal data, and how to think your way out of the box. So we have here, the first column, we have education. So there is an assumption that 4 is greater than 3 and 2 and 1, meaning that as the code increase, there's also an increase in the respondents' education. 4 is coded as those who finish college, 3 high school graduate, and 2 elementary graduate. Then for number children, it's very easy because it's ordinal. There's no problem there. Age at marriage and monthly checkup. This is kind of semi-nominal, as I've said before, because we assume that those with regular has a greater value than those with irregular monthly checkup. That is the assumption. Next is types of family methods used. We have the assumption that 4 coded a respond coded with 4 is the most effective type of family method used, and 1 is least effective type of family method used, and years of using family planning. However, there are instances that are very nominal data, highly nominal data. For example, gender, nationality, color, and residence. The best thing you can do is to set a model. I refer it to as a landscape model. You just arrange them in a sense that from smallest to highest. And the best way to arrange them is through a reference point. For example, in terms of gender, we can code them as 0 as 1, 0 as male, and 1 female, 1 as male, and 2 as female. But in reference point to Roberts 2006 in reading attitudes, he said that females have better reading attitudes than male. Because of that, we code 1 male and 2 as female, and we code it as such because of this reference. We can always code 1 female and 2 female, but because of that reference, we made 2 female and 1 male. This will have bearing in the correlation later. In terms of nationality, using the person's nationality, why not use the GDP of the country, which it represents the nationality, and color from secondary to primary, or primary to secondary. In terms of residence, why not use distance from school, from the office, from the hospital or center, or from the office you are in? This is very important because how you code will have bearing on the results, and I will explain that with this example. Example number 1. We have a 25-point exam, and these are the genders. So male and female, very highly nominal. So we code female as 2 and male as 1. In fact, the mean of the male is 13.87 and the female is 20.37, and you can see that the female scores female 19, 23, 22, while the male scores are around 15, 17, 16, 18, 12. There is an already assumption that the female is greater than the male in reference point to Roberts 2006. So when we do our correlation, our data analysis, in terms of correlation, we'll get this one. Okay, we'll put labels in first row and put our data here and click on output range here. We will have this result that there is a 0.653 correlation. What if, I'm just showing the importance of coding, what if there is a mistake in your part or a lapsus in your part that you coded 1 as female and 2 as male, because you just choose it randomly because you think it's random. However, still the result is inverse. We have male, instead of coding female as 2, we coded female as 1, 1, 1, and the male as 2. Actually the same data. So what will happen here, there's an inverse. Female is 13.875 and the male has 20.375. So what will happen to the data? We'll click on correlation, erase this data here, and we'll click on this data. Output range here. As you'll notice, the same correlation happens, however, there is a negative. What does that mean? In correlation, you measure the relationship between x and y. As x increases, y also increases. So in this case, as the number shifts from 1 to 2, the values, their scores actually decreases. However, in this case, as the values shift from 1 to 2, the value actually increases. And that is very critical, because when you see a negative number there and you don't know what it means, it will have a lot of implications in how you defend your paper, how do you interpret the data. I hope you understand that. So let's go to a slightly more ordinal data. For example, we have a 25-point exam and distance from school and their score. So let's do data analysis for that. As you will notice that the higher sample, let's take the lowest. That's 2. 1 kilometer from school, it's only 22. And 4 is 19. 3 is 23. So we'll check the correlation. So we have correlation here. Erase the data. The rows for data, we'll click on that data there. So data, distance from school, and output range. Okay, so as you can see here, there's a positive correlation. As the number increases, the distance from school increases, there's also that increase in the score of the student or in the respondent. However, changing the data from 5 5 to 1 and 1 to 5, 4 to 2 and 2 to 4 and 3 as S, you'll realize that, erase that one, columns, and distance from school, output range, and okay, same values, however a negative. Why is that? Because of the conditions that we change the distance from 1 to 5 to 1, 5 to 1 and 1 to 5, 4 to 2 to 2 to 4 and 3 as S. Meaning as the values, the distance increase, there is always also a decrease in the score. However, in this case, as the values increase, there is also an increase in the score, and that is what correlation is about. It is measuring the relationship of two variables. How do you say that the variables, there will always be that positive and negative correlation? However, how would you know if the correlation is negligible, low, moderate, substantial, or highly correlated? With the conditions that a negative R means an increase in the R inverse relationship. As the independent increase, there is a decrease in the dependent. As the independent decrease, there is also an increase in the dependent. So let's see here. So we have this. So we'll try to look at the correlation between age and leadership. As you will notice that as age progresses, there's also a increase of leadership or leadership potential. So when we do data analysis for this one, remove this one, remove, and we'll have this one here. And there. So if you notice, there's an increase. So this means that as the age increase, there is also a positive correlation between age and leadership. As age increase, leadership increase. But we have to look at these parameters. For example, that's the result is 97. So there is a high to very high relationship between age and leadership, meaning that as age increase, leadership increase. That's easy because that's nominal. How about going to this one? Okay, this one is also distance from school. As the distance increase, there's also a increase of number. However, it's only 2.23, so it's a low correlation. So these are your parameters from which you can say if it's negligible, low, moderate, substantial, or very high, because there will always be that positive or negative increase. However, the question is it significant? So that's it. So thank you. Good day. Please you're viewing, like and subscribe. Thank you and have a great day.